Hello students, welcome back to subject of complex variable and partial differential equation. Myself Dr. Ankit Acharya, and as you all know that from some of the lectures we discuss about how we can find complementary function for homogeneous linear partial differential equation with constant coefficient. So again let's take a quick revision. You have to remember this formula, right? You have to remember this formula for to find complementary function. If your roots of auxiliary equation are different, then what is your complementary function? That is f1 y plus n1x plus f2 y plus n2x plus up to fn y plus mnx. Okay, if two roots m1 and m2 are equal and other roots are different, then formula for complementary function for this type of auxiliary equation is f1 y plus n1x plus x into f2 y plus n1x, and other roots are distinct, so you can write as it is. If three roots are equal, then complementary function is f1 y plus n1x plus x f2 y plus n1x plus x square f3 y plus n1x, and from m4 all roots are different, so you can write as it is. Okay, so this is our next example. Solve del cube z by del x cube minus 3 del cube z by del x square del y plus 2 del cube z by del y cube, that is equal to 0. This example is quite different, so try to understand very carefully. Now first of all, what is the equation of f of d d dash? The equation of f of d d dash, that is equal to d cube minus 3 d square d dash plus 2 d dash cube, that is equal to 0. Okay, so the equation of m, I can write m cube minus 3 m square plus 2, that is equal to 0, and the value of m, that is equal to d by d dash. The value of m is nothing but d by d dash. Okay, now I want to find out the roots of this third degree polynomial, m cube minus 3m square plus 2, that is equal to 0. So first of all you have to find out at least one root from this equation, and after that you can apply our synthetic division method that you already know, you already apply in your lower standard. Okay, so if you can understand, when I take m is equal to 1, so that satisfied this equation. 1 raised to 3, 1 plus 2, 3, 3 minus 3, that is equal to 0. So definitely 1 is our first root. Okay, so 1, okay, m is equal to 1, m is equal to 1 is our root, right? Is our root of this equation. Now apply our synthetic division method to find out other roots. So first of all I write the coefficient of m cube, that is 1, then coefficient of m square, that is minus 3, then coefficient of m, that is 0, and the constant term, that is 2. Okay, and what is my one root? One root is, okay, what is my one root? One root is 1. So that's why first root, I can say first root, okay, that is 1. So that's why I write here 1. Now we have to add here 0, then 1 plus 0, 1, then 1 into 1, 1 minus 3 plus 1, minus 2, 1 into minus 2, that is minus 2, 0 minus 2, that is minus 2, 1 into minus 2, okay, that is minus 2, and definitely here we get 0. So the other factorization is m square minus 2m minus 2, that is equal to 0. So I can write one factorization is m minus 1. The second factorization is m square minus 2m minus 2. So m square, okay, m square minus 2m minus 2, that is equal to 0. So now I have to factorize this equation, m square minus 2m minus 2 is equal to 0, using my this method. So m is equal to, I can write minus b plus or minus square root of b square minus 4ac divided by 2a. Okay, so what is my b? A is 1, b is minus 2, c is also minus 2. So here we have 2 plus or minus square root of b square is 4 minus 4 the value of A is 1, the value of C, that is minus 2. So minus 4 into minus 2 divided by 2, right? So this equal to 2 plus or minus square root of 4 plus 8. So that is square root of 12. Square root of 12, I can write 2 root 3. So 2 root 3 divided by 2. So finally I have 1 plus or minus, okay, 2 will be cancelled out. So 1 plus or minus root 3. So now we have 3 roots. 3 of them are different root. First root is m is equal to 1, right? Second is 1 plus root 3 and then 1 minus root 3. Okay. So that's why I can write complementary function. Complementary function is f1 y plus x, then plus f2 y plus 1 plus root 3 into x and plus f3 y plus 1 minus root 3 into x. So this is my complementary function, and again here particular integral is 0 because right side we have 0, so z is nothing but complementary function, and complementary function is f1 y plus x. Just write down once again, f1 y plus x plus f2 y plus 1 plus root 3 into x plus f3 y plus 1 minus root 3 into x. Okay. Now next concept is rules for finding the particular integral, right? Now in particular integral there are 5 cases in your syllabus, okay, and particular integral is depend upon this f of x1, okay. So different rule for different function, right? So case 1, first of all, what is your particular integral? We know that this is our general equation, okay. F of d dash into z, that is equal to f of xy. So this is a formula for particular integral, 1 upon f of d dash into f of x1, right? So this is my formula to find particular integral. And now this is my first rule for case 1. If f of xy that is equal to e raised to ax plus by, if f of xy is a function of e raised to ax plus by, for that you have to follow this rule. Particular integral that is equal to 1 upon f of d dash into e raised to ax plus by, okay. And first of all take d is equal to a, right? Simple rule, just instead of d you have to take a, right? Instead of d you have to take a, and instead of d dash you have to take b, right? But the condition is f of ab must be non-zero. That means denominator must be non-zero. Otherwise this rule we cannot apply. Suppose denominator becomes 0, that means what? F of ab becomes 0. Then you have to follow this rule, our second rule, okay, multiply with x, okay, 1 upon f dash ab. F dash means you have to differentiate of this function, with respect to d, okay. So here I already mentioned the note, differentiation with respect to d of f of d dash, not with respect to d dash, okay, with respect to d. And in that term again you have to follow this rule, instead of d you have to take a, and instead of d dash you have to take b. Suppose again f dash ab is equal to 0, so now you can understand, multiply with x square, again differentiation f double dash ab, and put find out the value of f double dash ab, okay. So let's solve one first example for this type of example, okay. So del cube z by del x cube minus 3 del cube z by del x square del y plus 2 del cube z by del y cube, that is equal to e raised to 2x plus y. Now if you remember, just we solve in today's lecture, just we solve this example, but we find only complementary function, okay. So definitely what is our complementary function? If you remember the same equation, see in previous example, the same equation here we have del cube z by del x cube minus 3 del cube z by del x square del y plus 2 del cube z by del y cube, okay, that is equal to 0. The same equation we have, and we already find our complementary function, right? So this is my complementary function here. So directly I write complementary function here, don't be confused, okay. f1 y plus x plus f2 y plus 1 plus root 3 into x, okay, clear, and plus f3 y plus 1 minus root 3 into x, okay. Now my main concept is to find particular integral, and to find particular integral is 1 upon, what is my equation of f of d dash? This is nothing but dq minus 3 d square d dash plus 2 d dash q into e raised to 2x plus 1, okay. So clearly you can understand, just take 2 instead of d, so this is 2 raised to 3, right, 8, right, and this is, so 1 upon, just write 1 upon 8 minus 3 into, right, don't be confused here, a is equal to 2 and b is equal to 1, okay. So I take 2 instead of d and 1 instead of d dash, so 3 into 2 square, right, into 1, so plus 2 into 1 raised to 3. So you can see that 8 plus 2, 10, and this is 4 into 3, minus 12. So 10 minus 12, that is minus 2. So that's why our final answer is minus 1 by 2, okay, minus 1 by 2, right. Our final answer, particular integral, is nothing but minus 1 by 2 e raised to 2x plus 1, okay. This is my particular integral. What is my z? The value of z is nothing but complementary function plus particular integral. So write down the final solution, that is f1 y plus x plus f2 y plus 1 plus root 3 into x, okay, plus f3 y plus 1 minus root 3 into x. So this is my particular integral, plus this is my complementary function plus particular integral. So minus 1 by 2 e raised to 2x plus 1, okay. So in particular integral, just we discuss about our first case, case 1, where function is e raised to ax plus b1. In that case, just we have to take a instead of d and take b instead of d dash. Make sure your denominator must be non-zero, and just we solve our first example for case 1 to find particular integral. So thank you.